So I hope my audio and video are visible to everyone. Please let me know in the comment section whether my audio and video is visible to you all or not. Okay, so basically in the last session, if you remember, we have covered the mathematical tools and we have seen what are the important mathematical tools that are required. Now in this session, we are going to start our very important chapter, that is a motion in a straight line. Okay, in this chapter we are going to see only those important points which is necessary, as you have seen that our crash course is going to see those important points which are necessary for solving the questions. Okay, after completing these two chapters we are going for a practice session for these two, separately for these two chapters only. Okay, and our focus will be the previous year questions, because that will build up more confidence for you. Clear? So let us start. So our next chapter is motion in straight line, or you can say 1D. Okay, motion in 1D, one dimensions. Okay, so whenever we talk about the motion in one dimension, the first thing which come into our picture is the distance. What is distance? See, there are the few important points which I am writing. First is, it is the actual path length. Actual path length. Okay, actual path length called as a distance. First point. Second point, it is a scalar quantity. I hope you know what is a scalar quantity and what is a vector quantity. Means it has a only magnitude. Okay, it has a only magnitude. Third point, it is always a positive. Always positive. It can never be negative. It is always a positive. Second thing, if it is always a positive, that means it always increase. It always increase. Correct? Any doubt? Depend upon path. Like what type of path it is, depend on path. 6 point. And what is a SI unit? That you know, it is meter. If I ask you the dimension, if you ask you to write the dimension, so distance will be that is a dimension. So basically what I am trying to understand, a distance has following these properties. This is are the property of a distance. Just note it down. I will give you the proper example also, so that you will understand it better. Okay, just for now note it. Okay, note it down about the distance. 1 minute. Okay, clear? So this is about the distance. Next is displacement. Next is displacement. If we talk about the displacement, the first thing is that it is a shortest path. It is a shortest path between initial point and final point. Initial point and final point. Clear? Second point. It is a vector quantity. Third point. Maybe it will increase or decrease. It depends. Okay, it depends. It can increase as well as it can decrease. Fourth point, as it is a vector quantity, it may be positive, negative, and zero. Anything, three things can be possible. Second thing, it does not depend upon the path. And sixth thing, what is the SI unit? SI unit is same, meter. And if you talk about the dimension also, okay, dimension of displacement, this dimension is again the same. But what is the important difference is there? What are the important difference? Important difference is, suppose if you talk about displacement, there are the two cases can be possible. One is this case and one is this case. What do you mean by these two cases? What I am trying to say, if you move in this direction, you will take it as a positive. If you move in this direction, you will take it as a negative. Similarly, if you move above, you will take displacement as positive, otherwise you will take displacement as negative. This is a sign convention. This is called as a sign convention. Okay, sign convention. Clear? This is called as a sign convention. But basically what I am trying to explain from these two, that suppose this is 1.1 and this is a point 2, 1 and 2. Suppose there are the two paths is there. One path is like this, one point path is like this, two paths are there, okay, and one path is like this. If I ask you the distance, suppose d1, d2, d3, these three are distance. So you can say, sir, d3 will be greater than d2 than d1. Basically, when we're talking about a distance, we are measuring how much distance we had traveled. Okay, how much path we have covered. So here, from here to here, we have covered a more path than here as compared to here. So that is the distance. But if you talk about the displacement, displacement means shortest distance between the initial and final point, shortest distance or shortest path. See, the shortest path is this one, no? This one. Okay, this is the shortest path. This is the shortest path. So that means this is the displacement. This is a displacement. So displacement is 1. Okay, 1 is a displacement, whether 2 and 3 is not a displacement. Are you getting my point? So remember that displacement is the shortest path and distance is the actual path. Okay, clear? Any doubt? Okay, next thing, a very important note is, this is a very important note. Remember, distance distance is always greater than equal to displacement. Okay, distance is always either greater than or equal to displacement. Second thing, distance is equal to displacement only one case. What is that case? When the path is a straight line. Okay, whenever the path is a straight line, then in that case distance is equal to displacement when path is a straight line. Whenever the path is a straight line, then in that case my distance and displacement both are same. Okay, without changing the direction. Remember that there is a one condition also, without changing the direction. Okay, otherwise it will be not same. Without changing the direction, condition is that without changing the direction. Second point. Third last point from here which I can write, distance by mod of displacement is always greater than equal to 1. Why I am not putting mod here? Because distance is always a positive quantity, but displacement can be positive, negative or 0. So this thing will be always greater than equal to 1. So I hope you understand about the distance and displacement. Distance simply means a path length, okay, and displacement means the shortest path length. Simple thing, simple logic. Okay, Nothing too much complex or difficult for you. Simple logic. Clear? Okay. Next point. After that is a position vector. If you know about the position vector or not. Okay. Position vector. If someone have a doubt regarding vectors, I will like to tell you that you can go to this channel and there is a separate lecture series for vectors are there. At least that is a very small lecture series. You can go and see that video to complete your vectors part. Okay, because vectors are very important. In this crash course, it is very difficult to teach you the vectors because it will be a separate chapter. So it is better you can go there and you can cover the vectors if you have any doubt. But I will try to complete most of the topic which is required for you. Okay. Yeah. So what is position vector basically? Suppose I have a x-axis and I have a y-axis. Okay. And suppose there is a one vector like this and another vector like this. Correct? And there is a one vector we are drawing from here to here. Are you getting my point? This vector I am taking as r1 vector. This I am taking as r2 vector. Okay, suppose this point will be x2 comma y2. I am taking in 2D. You can take in 3D also. No issue. Only one point will be extra. Then what is that s vector? See this x vector. If I apply the triangle law of addition, r2 plus s vector is equal to r1 vector. So my s vector will be equal to r1 vector minus r2 vector. Now how to write r1 vector? R1 vector will be simply defined as x1 I cap plus y1 j cap, x2 I cap, y2 j cap, x1 minus y2 j cap. So if I calculate the distance or magnitude, it will be this vector will be this thing, correct? And this is called as a s vector. How will you write? So this is nothing but this thing is a position vector, this thing is a position vector. From there, how to write a vector? This is the form, and this is the distance between the 2 points. Sometime they will give you the coordinate like this and they will ask you the distance. That is the distance between these 2 points. Clear? And this is a position vector of that. S vector is that vector definition. This is how you will write it. So just I have given you the idea. If you want to know more about this, you can go and see that lecture series. But for now, this much is sufficient. Clear? Now the next important point is that is speed. Okay. Now what is speed? See, there are the two types of speeds are there for our syllabus. One is average. This is a favorite part of NEET examination, average speed, and another one is a instantaneous speed. What is average speed? When we measure the speed for a longer duration of time, that is the average speed. And when we measure the speed at a particular instant, this is at particular instant. Okay, this we talk about at a particular instant, or this during a time interval. During a time interval, some time interval we used to do that. During a time interval, correct? First thing is that scalar quantity. If you talk about the speed is a scalar quantity. Second thing, if it is a scalar quantity, it will be always positive for a moving body. Remember, if the body is moving, then only it will be there. otherwise it will be 0. Okay, for moving body, if the body is moving, then only we have a speed which is positive. SI unit is what? Meter per second. And what is the dimension formula? Can you tell me what is the dimension formula for this? That is meter per second, LT minus 1. Correct. Now what is the formula for average speed? The average speed is defined as, remember the formula, it will be very much similar to the average velocity we will discuss. So it is defined as total distance, okay, not displacement, total distance by total time. Okay, suppose you are covering some distance, you have to take that total distance and you have to divide by total time, that is going to be your average speed. Simple. Okay, let's see some cases on this, then you will understand it better. Let us see some cases. Okay, some cases we will see to understand this formula more in a better way. First case. Okay, suppose it is a path. Okay, suppose it is a path and this point is A, this point is C, this point is B. Okay, suppose this point is S1, this point is S2, this distance is S1, this distance is S2, and this time is T1, this time is T2. So what is my average speed? AS. Average speed AS. Okay, or you can write it as V average. Okay, V average. I am not putting vector sign, okay, because it is a scalar quantity. That is defined as total distance S1 plus S2 divided by T1 plus. Correct. Next is key points. What are the key points in this case? First important case, that if suppose my T1 is equal to T2. Okay, suppose my time is same, then in that case my V average will be how much? What will be my V average? What I am trying to say, suppose my time will be same. What I am trying to say, suppose this is a distance, okay, and I am saying this point is A, this point is B, sorry, B, T1, this point is T2, and this velocity is V1, this velocity is V2. So what is V average in this case? V1 plus V2 divided by 2. Simple. You just take the two velocities and take the average of this speed and take the average, because T1 and T2 both are same in this case. Second case I am taking when S1 is equal to S2, that is equal to S. Okay, means distance is same. Distance is same. In that case time is same, here distance is same. Then if this is the case, then V average is simply defined as 2 times of V1 V2 upon V1 plus V2. Correct? 2 times of V1 V2 plus V1 plus V2. And if suppose in this case only, suppose I take some extra case, that is S1 is equal to S2, that is equal to S3, that is equal to S. Suppose 3 equal parts I have divided into 3 equal. Okay, then in that case my V average will be what? From here can you tell me? Yes, it is 2 times of V1 V2 V3. Correct? V1 V2 plus V2 V3 plus V3 V1. Are you getting my point? Clear? Any doubt till here? Okay, so this is how you can write the average speed. Okay, this is how you can write the average speed. Basically you have to remember the total distance upon total time. These are the some special cases which generally come into the questions. Okay, so these are the some special cases. We will see the some more questions on this, but yeah, these are the some special cases. If you remember, you can directly solve it. Next is Average velocity. What is the average velocity? This is called as average velocity. What is V average? Average velocity. Average velocity is defined as x2 vector by x1 vector divided by t2 minus t1. Correct? Is equal to delta x by delta t. Correct? That is x2 minus x1 divided by t2 minus t1, or you can say total displacement. You can say this like, say it like this, total displacement. याद रखो, this is sorry, by mistake I speak in Hindi. Remember that it is a total displacement by total distance, not a total time, not a total distance by total time. Okay, total displacement, it is a total displacement by total time. That is what it written here. Okay, it is the total displacement by total time. Second thing, direction of average, direction of V average velocity is same as that of displacement vector. Correct? Second thing, average speed is always greater than equal to, same as that of average like distance and displacement, average velocity. Correct? And when the average speed will be equal to average velocity, what is the condition? What will be the condition? Think and tell. What will be the condition when the average velocity is equal to average speed? What is that condition? When particle is moving in a straight line without change in direction, without the change in direction, then in that case only we will get my average velocity same as that of average speed. Correct? Now second thing is V average instantaneous. Okay, what is that? What is that? See, this is the same thing. If you remember, I mentioned that whenever we are talking about an instant, means at a particular time. Okay, so here also, if I am defining my V average, V vector means it is a instantaneous velocity. That is V instantaneous is equal to dx by dt, where what is x? X is a displacement vector. Remember, it is a displacement vector. Clear? And what is the meaning of that? What you can understand from there? You can understand from there that it is defined as a slope of displacement vector, or you can say slope of displacement time graph is the slope of a displacement time graph. As I told you differentiation means is a slope of y versus x curve. So from here also we can say it is a slope of displacement versus time curve. Displacement versus time curve. Clear? And what is the direction? If I ask you what will be the direction? The direction, because it is a vector quantity, so magnitude and direction both are important. Direction of v instantaneous. What is the direction of v instantaneous? Is same as or you can say whenever we talk about the direction of a instantaneous is tangential to the curve or path, tangential to the curve or to the path. Clear? Is tangential to the curve or to the path. That is basically means what I am trying to say. Suppose my motion of the particle is like this. Okay, so at this point what is my v instantaneous is draw the tangent. What is the v instantaneous? Draw the tangent. What is the v instantaneous? Draw the tangent like this. So the direction will be along the tangent. Suppose at this point I am asking draw the tangent. This is the direction of v instantaneous. That is what I am trying to say. V instantaneous at this point, this direction, this direction, this direction, like this. So its direction will be the tangent to that path. Okay, whenever you draw the tangent, you will get the direction of that v instantaneous at that path. Correct? Next point is a very important point is that is in motion in a straight line. That is a very important, because these notes are very important for solving the numerical. Suppose I am moving in a straight line. Okay, suppose I am moving in a straight line like this. Now suppose I have to reverse my direction. Means what I am trying to say, suppose I am moving like this and now I want to reverse my direction. So for that I have to make my velocity 0 here. Then only I can make my velocity negative. See, when I'm moving from here to here, my velocity is positive. Okay, positive direction. Now I want to change the direction. That means I want to change my velocity from positive to negative. Okay, so for that I have to make my velocity equal to 0. So that is what the note is. If whenever we want to reverse the direction, whenever in a straight line we want to reverse the direction, we has to become zero. V has to become 0 at turning point. Turning point. That is true. So I can say my displacement, in that case my displacement may become 0, can be 0. Why? See, I am moving like this. I came here, stop. My velocity at this instant will become 0. Then I turn. Okay, and then I am moving like this. Okay, now my velocity is negative. Now my initial point and final point both you can see it's same. So the displacement is 0, but it is not always necessary. So we can say that displacement cannot be equal to distance in this case. Okay, may I can stop here also. Then there will be some displacement like this. So this can be possible. Means what I am trying to say, I am start moving from here, I went here, I stop there, then I turn, and then I move and again come here. Displacement is 0, but there may be possibility I can do like this also. I move up to here, okay, stop, my velocity is 0 here, then I move, I turn my direction, then I move up to here only. I don't went to that position. Then there will be some displacement will be there. So that is what I am saying. The distance is not equal to the displacement. Okay, if the particle has changed its direction. Okay, distance and not equal to the displacement when particle change its direction. When particle change the direction. This is the case. This is a very important case. Whenever you are changing the direction, the distance and displacement won't be remain same. Clear? Note it down. Acceleration. Now I think everyone know what is about acceleration. What is acceleration? See, as we have velocity, we have instantaneous velocity, we have average velocity, we have instantaneous speed, we have average speed. Similarly, here also, we will have a what? We will have a instantaneous as well as average. Instantaneous meaning you understand at a particular instant. Okay, and average means during a time interval. Okay, correct. So let us start writing some important points. First thing, what is that? It is a rate of change of velocity. Rate of change of velocity. Remember, I am not writing rate of change of speed. It is a rate of change of velocity. First thing. Second thing, it is a vector quantity. It is a vector quantity. Third thing, sorry, if acceleration is there, then either velocity, direction, or magnitude will change, or both. Means either there will be change in the direction, either there will be change in the magnitude, or either both of the values will change. Clear? Third important point, what is the SI unit? SI unit is simple, meter per second minus 2. Or if you ask me about the dimension of acceleration, acceleration dimension is very clear, that is defined as LT minus 2. Correct? Similarly, if you ask me what is average acceleration, sir, average acceleration is simply defined as change of velocity by time interval, or you can write it as v2 minus v1 vector divided by t2 minus, that is the change in velocity by time interval. Okay, now what is the important thing is that what is the direction, what is the direction of that average velocity, average acceleration. So direction, remember the direction is always along the change in velocity. Okay, the direction of acceleration is always along change in, always along the change in velocity. It is always along the change in velocity. Okay, similarly we have instantaneous acceleration. What is instantaneous? Instantaneous acceleration, if I ask you, what you will say? It will be dv by dt vector. Clear? dv by dt vector, that is the instantaneous acceleration. But what is v vector? Sir, v vector is dx vector by dt vector. So can I say my acceleration will be, sir, d square x by dt vector, correct? And this can be written as v dv by dx. So these are the different differential, you can say, formulas for acceleration. So the different formula for acceleration, and from here, can you tell me what is the conclusion you get from here? If you understand my differentiation mathematical tool, so can you tell me what is the conclusion from this line? Acceleration is a slope of velocity time graph. Okay, it is a slope of a velocity time graph. Clear? Any doubt till here? Okay, so please note it down. Please note it down fast. Completed? Okay. Now the next thing is that, remember, when the velocity, when velocity is along direction of acceleration, whenever the velocity is along the direction of acceleration, in that case, what will happen? What is going to be happen? If my velocity and acceleration are both in the same direction, then what will happen? In that case, you can see my speed will going to increase. Okay, either sorry, when my velocity is opposite the direction of acceleration, what is going to be happen? My speed is going to be decrease. Means there will be decrease in speed, and the increase in speed is, this is termed as a acceleration. This is termed as a acceleration. Okay, and this is termed as a retardation. Okay, this is termed as a retardation. So acceleration is basically a phenomena. You try to understand. Acceleration is not something like that. It is a phenomena. Okay, so it's basically a type of phenomena which is happening. Okay. So what I'm trying to say, if suppose this is my acceleration, okay, I am taking, suppose this direction is positive, and suppose this is my velocity, okay, and that is also positive, then what I am going to be happen, my speed is always going to increase. That is what I am trying to say. Suppose this is my acceleration, okay, and it is negative in this case, because maybe I am taking this direction as negative, and suppose this is my velocity and it is positive in this case. So what is going to be happen to the speed? My speed is going to be decrease. The speed is going to be decreased, correct? Okay, suppose velocity is going to be positive and my acceleration in this case is negative. Again, what is going to be happen? They are in the opposite direction. So my speed is going to be what? Increase or decrease? It is going to be decrease. That is third case, correct? Second case, what is going to, suppose this is my velocity. Velocity is going to be positive, correct? And suppose my acceleration is is positive also, like this. So what is going to be happen? My speed is going to be increase, correct? So these are the different cases. Suppose my velocity is negative and my acceleration is also negative, and in this case most of the people think that okay sir, velocity is the speed is going to decrease, but no, if they both are in the same direction, my speed will be increase. Just you have to see the direction. If the direction is same, then it doesn't matter whether it is positive or negative. That is our sign convenience na. We have defined our sign convenience. On the basis of that we are defining the direction. But if they are in the same direction, it will is acceleration. If they both are in different direction, then it is a retardation. Simple thing. Clear? Any doubt? I hope there won't be any doubt. If any doubt, please let me know in the comment section. Next thing is, that is, what is uniform motion? Uniform motion simply means when an equal time interval we cover an equal distance. Okay, that is called as a uniform motion. Simple thing. When we covered equal distance in equal time interval. Okay, when we covered equal distance in an equal time interval is called as a uniform motion. Simple. Second thing, non-uniform motion. What do you mean by non-uniform motion? See, everything is same. When we covered unequal distance in an equal time interval, okay? When we covered unequal distance in equal time interval, okay, that is called as a non-uniform motion. Clear? So this is a basic theory part which are present in this chapter. I hope it is very much clear to you. First we have started with distance, and then we go to the displacement, then we move to the position vector, and then we understand about the speed, average speed, what is the important cases. Then we have seen the average velocity, then we have seen the v instantaneous. Similarly, we have seen the acceleration, then we have seen what is acceleration formula, then we went to the when there will be acceleration, when there will be retardation. Clear? Okay. Now let me provide you the one formula sheet which is very important for you. Okay, let me give you a one formula sheet which is going to be very important for you. Okay, this is a conversion formula. Okay, formula conversion for you. See, so we will have a suppose we will have a displacement. If you remember this now, then it is very easy for you. Displacement, then velocity, and the last thing is acceleration. Okay, if this is the thing, so from here to here, how to come? That is a formula change. Okay, suppose I have a displacement, I want to go to velocity. So simply what you have to do, if you have to come from here to here, you have to find velocity is equal to dx by dt. That is a simple thing. You have to do differentiation. Differentiation. You have to do differentiation. Are you getting my point? Here. Now from here to here, if I have to come, again I have to do differentiation. Okay, first case, my acceleration will be equal to dv by dt. Second case, my acceleration will be equal to d square x upon dt square. And third case, my acceleration will be equal to v dv by dx. Okay, this formula we have to use when v is a function of x. So that is the conversion from here to here. Now if I have to go from here to here and then from here to here, okay, so first thing, from here to here you have to do the integration. That is very much clear. You have to go from here to here by integration. Integration means acceleration a dot dt is equal to change in velocity. Simple. Okay, then from here to here, if I want to go, what I will do, I will integrate v dot dt, that is equal to delta x. Clear? Displacement vector basically, and this is also a integration. So I hope you are getting the point. Okay, basically I hope you are understanding what you have to do. If suppose either they will give you this case or either they will give you this case. Okay, so if this is the case, then this you have to do, and if this is the case, then what you have to do, you have to do acceleration a dot ds into v vector dot dv vector. That is a two cases which can be possible, that can be given. When is this case? If my acceleration is a function of x, okay, then you have to do this case. So that is a formula sheet for you. Okay, a formula sheet, very clear up to the point, so that you can have no confusion regarding the formulas. Okay, you can understand where, at which point we have to apply which formula. Okay, at least you can understand. Clear? Okay. Okay, just take the screenshot of this first. Then okay, next thing is same formulas only. So a lot of people has a confusion regarding the graphs also. So acceleration, okay, velocity and displacement. Okay, these three things are there. So this is defined as a slope of xt curve. If you take xt curve, then it is defined as a velocity. Yes, this is defined as a velocity. From here to here, if I have to come, then it is slope of vt curve. 1 minute. Vt graph, that is defined as a acceleration. Okay, suppose I have to go from here to here. Okay, acceleration to velocity, that is what, this is defined as a area under the at graph, is defined as a change in velocity. Okay, change in velocity, and from here to here, if I have to go, then it is defined as a area under vt graph, that is defined as a distance as well as displacement. How? How, sir? This is the doubt. How? Let us see how it is like this. Suppose I have a graph like this, and here suppose the graph is like something like this. This is my velocity, this is my time. So this area will be what? Positive a1. This area will be minus a2. So if I want to calculate the displacement, my displacement x vector will be equal to a1 minus a2. This is my displacement. Whereas my distance x is equal to a1 plus a2. Means you have to take the sign only. That is my distance. This is thing is distance. Okay. And this thing is displacement. So when we are talking about the displacement, we have to take the sign also, whatever the sign we are getting. But when we are talking about the distance, we have to take only the magnitude. There is a no need to take the sign. Okay. That is, there is a no need to take the sign. That is what I am trying to say you. Are you getting the point? Clear? Clear? Okay. Note it down. Okay. Now the next is a favorite topic, that is equation of motion. See, derivation is not important for you. From where you have get this derivation, no need to know that. Just there are four equations are there. V is equal to u plus at. Second, s is equal to ut plus half at square. And third is v square is equal to u square plus 2as. Okay, and the last thing is s and th. That is what? That is u by 2. Sorry, not u by 2. It is u plus a by 2, 2n minus 1. Okay, that is distance in nth second. Distance in nth second. First of all, what are the small terms? What are the terms here? Like, what is v? V is a final velocity. Final velocity. What is u? U is the initial. Not velocity. V is equal to initial speed. U is equal to final speed. A is equal to acceleration. And remember, here s is displacement. It is not distance, it is a displacement. And these formulas are applicable only when acceleration is constant. Okay, whenever my acceleration is constant, then this formula is applicable to you. Okay, that is a correct equation of motion. Clear? Okay, but okay sir, if acceleration is not constant, then what you will do? If acceleration is not constant, then we have another equations now. If you remember, what are those equations? Then what are those equations? The first is v is equal to dx by dt. That is the first equation. Second equation, a is equal to dv by dt. And what is the third equation? A is equal to v dv by dx. So from here I can write this equation also. V dt is equal to integration of dx. Just you have to do the integration. A dot dt is equal to integration of dv, and a ds integration will give v dv. Clear? So this is formulas when the accelerations are not constant. Okay, these are the formulas you have to use when my acceleration is not constant. Clear? Take the screenshot of this. Clear? Okay. Next thing is important points. You can say key points. What are the key points? Okay. Suppose this is my some path. Okay, this distance is x, this distance is s. This is the initial point, this is the final point, and suppose this is v mid. Okay, then condition is that v mid, they will ask you what is v mid. So v mid is simply v plus u divided by 2, v square plus u square divided by 2. That is the first thing. Second thing, they will ask you what is s. S is will be u plus v divided by 2 into t. Second thing, they can ask you what is v average, and in that case v vector plus u vector divided by 2. Clear? These are the different things what they can ask, I am telling you. Second one, famous question is that, suppose it is a very famous question, most of the time it came into the exam. Suppose this is my particle, initial velocity is 0, okay, and it is moving with a acceleration of alpha meter per second square. Okay, it is moving with the acceleration of alpha meter per second square, and then it reaches a v max. After that, it in the time interval t2, this is time interval t1, it start decreasing with a beta meter per second square. It start retarding. Okay, velocities start decreasing, and finally again the final velocity will become 0 because it will be retarding. So first thing is, what is my v max? What is my v max? Okay, if you will see, what is the first question? My first question will be, what is my first thing? Suppose s total, like if I ask you what is the total displacement, the total displacement will be half alpha beta on alpha plus beta into what is the time t square. Second thing, I will ask you what is v max. So v max will be simply equal to alpha beta upon alpha plus beta into time t. And what is the relation between time t1 alpha into beta t2? That is a relation. Okay, that is a relation. Are you getting my point? That is a relation. Anything else? So this is a very famous question. Okay, this is the question statement. They will ask you s total, v max, and relation between alpha beta and t1 and t2. These are the famous questions they can ask with respect to this. Clear? Clear? Okay. Any doubt up to here? We can proceed further. Let's talk about graphs. Okay, we have seen what are the different things in graphs, but let us discuss more about in detail. Okay, what is graph? Okay, so let us start. Okay, 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 so this angle is suppose theta, clear, and this is my time and this is my displacement. Okay, what is the slope of displacement versus time curve? That is a velocity. Okay, so slope of displacement versus time is velocity. Clear? Slope of displacement versus time is velocity. Second thing, if I am saying my velocity is constant, is constant. Velocity constant means if my velocity is constant, then slope should be, then slope of displacement versus time should be constant. Should be constant, correct or not? So let us see here. Let me delete. Okay, so what I am trying to say, I am saying the whenever my velocity is constant, when my velocity is constant, then the slope of displacement versus time should be constant. Now there are the two cases when the velocity will be constant. First case, when the body is at rest. First case, when body is at rest. Body is at rest means what is going to be happen? My velocity will become 0. That means my slope should be 0. Here you can see my slope is what? 0. If this is a distance displacement versus time, here also 0, correct? Here also 0, correct or not? So in all the cases you can see my velocity is 0. In all the cases my velocity is 0. Are you getting my point? I hope you are understanding what I am trying to say. Are you getting? Basically, there will be two cases when the velocity will be constant. First case, when the body is at rest. Second case, when body is doing a uniform motion. Doing uniform motion means equal distance in equal interval of time. Then in that case, my velocity will be constant. And in that case, what are the curves I will get? What are the different types of curve you will get? Logically think. First is this curve. Second, sorry. Okay. This curve. Okay, so that is three cases. Clear? So during uniform motion, the velocity should be constant. See, the velocity is constant. Oh, sorry. This 1 minute. Velocity will be constant, correct? Velocity will be constant. So Vt curve. See, the velocity is constant here. Here, the slope is constant. It is a straight line which has a constant slope. Slope is constant, so it is a constant velocity. Here you can see the velocity is constant. Acceleration, what will be the acceleration? If the velocity will be constant, the acceleration will become zero. Obviously, if the velocity is constant, then differentiation of constant with respect to time, I told you what is the differentiation of constant? That is zero. That means my acceleration will become zero in that case. So that is what I am trying to say by this graphs. Okay. Are you getting my point or not? Are you getting my point? Okay. Next case. It's not a case, but let me tell you one thing. Whenever we talk about how to see slope, okay, how to see slope. It's not a some topic. It's a general idea. Because slope is going to determine everything now. So you should know how to see the slope. That is very important. Suppose this is my x-axis, this is my y-axis, and suppose I have a some curve. Okay, something like this. Okay, something like this. How to see slope? Basically, what is the approach to see the slope? Whenever you have to see the slope at a particular point, you just draw the tangent at that point. Just draw the tangent at that point. Okay, just draw the tangent at that point and just extend this line to the x-axis. You will get some angle theta 1. Clear? Now let's take another point, this point, and suppose this is xt curve. Okay, suppose this is xt curve. Now at this point you again draw one tangent at this point. And you extend it. Again you are getting some theta 2. What you can see from here, sir, theta 2 is greater than theta 1, correct? So slope is increasing, correct or not? So can I say my speed will increase? Yes. So that is how you have to see. Okay, are you getting my point? So similarly, I can take any curve. It doesn't matter. I can take any curve. I have to know how to check the slope. Whenever you have to check the slope at any point, just draw the tangent at that point and extend it to the x-axis. Extend it to the x-axis. After that, try to understand and try to see the change in angle. If the angle is increasing, see from here we have seen the angle is increasing. That means my slope will increase, so my speed is increasing. So that is how you have to see and you have to analyze. This is a general concept. This is not a new thing. It's a general idea. It's a general idea to see to analyze the motion. This is the general idea. Okay, this is not some topic. It's a general idea for you how to analyze the thing. So that I hope you understand how to see. And in the like, don't be afraid. We will take some lot of we will do a lot of examples on this also, okay, in the practice sessions. So don't be just like sir is just telling about this. Okay, I will do some lot of examples also. Clear? So in today's session we have seen a lot of things in motion in a straight line, and we have covered the motion in a straight line. Basically we have seen all the concepts which is required for your solving the questions. There is a one small topic is there in the motion in straight line, that is a motion under a gravity. This is also come under a motion in a straight line, but I will teach you as a separate topic in the today's evening session. So till then, you just revise everything whatever I have covered here and start solving the previous year questions. We will also solve, but for you now, please start solving the previous year question. That is very important for your preparation. If you are solving previous year, I am giving you the guarantee you can achieve 180 out of 180, no problem. By seeing all these topics and by learning the things properly and by doing the hard work, you can achieve 180 out of 180. Clear? Till then, if you have enjoyed this session, if you have liked it, please share to everyone so that everyone come to know. Okay, please share it to everyone, because this is a quality content we are giving it to you. Okay, till then, take care, goodbye, have a nice day. Thank you.